When working through this problem, we notice we have denominators of 2 and 3, halves and thirds. With this, we want to multiply this entire equation by 6. So 6 times 1/2 would be 6 halves, or 3p. 6 times 1/3 would be 6 thirds, or 2. 6 times 2 thirds would be 12 thirds, or 4. And 6 times 1 is 6. This gives us a much cleaner equation to work with. Now I'm going to combine like terms, adding 2 to both sides. I have 3p equals 4p plus 8. I'm going to subtract 4p from both sides. I have a negative p equals 8, or multiplying everything by a negative 1, p equals a negative 8. Here I'm going to multiply the entire equation by 4 thirds. How did they choose that? I saw the reciprocal of 3/4. 4 thirds times 3/4 is just 1. Simplifying that equation, just p plus 2 equals, well, now I have 4 thirds p. But what's nice is 4 thirds, I'll do this off to the side, 4 thirds times 3 halves equals 4 over 2, or just 2. So now I have p plus 2 equals 4 thirds p plus 2. Notice when I subtract the 2's away, I have p equals 4 thirds p. And really the only thing that would p equaling 4 thirds p, the only answer that works here is 0. I could show this by subtracting 4 thirds p from both sides. P minus 4 thirds p will give me a negative 1/3 p. Still equals 0. So all in all, what I notice is p equals 0. Again, I'm going to look at this entire equation. I'm going to multiply by 5 over 1. Therefore, I'm simplifying this equation a little bit. 5 over 1 times 1/5 is just 1, and that's in front of that p plus 1, so it does leave me with just p plus 1 simplified on the left side. But that 5 needs to be multiplied to both terms on the right side. 10p plus 5. Now I'm going to combine like terms. So I'm going to subtract 1 from both sides. P equals 10p plus 4. Subtract 10p from both sides. I have a negative 9p equals 4. Divide by a negative 9. We'll see that p equals a negative 4/9.